Alright, we are going to look at the application of displacement. So let's look at this shape that is at the position of 0, 0. It's going at a displacement of 3i plus 4j, so it will be at this location. We can find the distance traveled by finding the magnitude of 3i plus 4j. Using Pythagoras theorem, the distance traveled is 5 kilometers. Another thing that we can find from this vector is the direction. So forming a right angle triangle using 3i plus 4j, we can use trigonometry to solve the angle tangent theta. So the angle is 36.9. So before we move on to more examples on velocity and displacement, let's do a simple recap on the formula. Velocity is displacement over time. Now, one thing that is different in this chapter is velocity and displacement. They are in I and J form. Alright, so now let's look at examples involving displacement and velocity. So this boat is at the origin 0, 0, is traveling at a velocity of 2i plus 2j. This means the boat is traveling at this direction. Okay, so let's look at the displacement at time t. So at the first hour, it is at 2i plus 2j. The second hour is at 4i plus 4j. And we can continue to find the displacement at any time t. So let's say t is 5, the displacement is 10i plus 10j. Okay, so the next example, now this ship now is no longer at the origin. It starts from 0, 2. The velocity is 2i plus j. So the displacement at time t, the first hour is 2i plus 3j. The second hour is 4i plus 4j. And we can continue to find, let's say t is 5. The displacement is 10i plus 7j. So we want to have a simple formula to help us find the displacement easily. So this is a formula of finding the position vector at any given time. R equals to A plus TV. R stands for the position vector of the object at any time t, which is what we want to find for this boat. And A is the initial position of the object, which is at 0, 2, and V is the velocity, and T is for time. In this case, is in hour. So let's find the position vector after 5 hours. So let's substitute into the formula, and we do some simple expanding and addition, and we'll get the position vector of after 5 hours, which is 10i plus 7j. Okay, now let's look at a little bit more complicated example. So it states here the position vector of ship A, which is RA, and ship B, they are as follows. So from these equations, we can see that they actually start at the same point. How we know that? This is A. They both share the same A, which is 1, 0 here. So these two ships, they start at the same position, but they are traveling at a different direction because of the velocity. So we can imagine they are going at a separate direction, and we are to find the vector AB after 3 hours. So let's substitute t equals to 3 into the formula to find the position vector of A and B. So we can get A is at 5, negative 5, 3, and then B is at 4, 6. and we want to find the vector AB. Actually, we do not need to use a graph to solve this. It's just for you to be able to see the movement clearer. So using a simple formula, AB is OB minus OA, and we substitute into the formula, and we can simplify it and find the vector AB, which is 9i plus 3j.